and welcome to this lesson on direct proportion. So this is the start of chapter 21, so hopefully this week you have already done your circle theorems revision lesson and have had a go at the knowledge recall. So moving on then to chapter 21, if you want to pause the video and have a go at the do now task, also write today's date and a title direct proportion. So the do now task then, when Mo Farah runs at 8 metres per second for some fixed period of time, he covers 240 metres. It asks you to fill in the gaps. So when he runs at a speed of 8 metres per second, he covers a distance of 240 metres. So if he doubles his speed and runs at a speed of 16 metres per second, what would his distance covered be? Well, hopefully you recognise that his distance covered will also be doubled. So this will give 480 metres. What if he halves his speed from 8 metres per second to 4 metres per second? Hopefully you recognise this would just half the distance covered. So this is 120 metres. And what about if he runs 3 times the speed, so he does 24 metres for every second? Well, his distance covered will have multiplied by 3 to give 720 metres. What numerical relationship then connects the speed and the distance in each case? So we've looked at how doubling doubles, so doubling the speed doubles the distance, but what about going from the speed to the distance? Is there a way from getting from the speed value to the distance each time? Well, hopefully you've recognised that we multiply by 30. So the speed and the distance are connected by what we call a constant scale factor of 30. So for this lesson then, we are going to look at solving problems where two variables have a directly proportional relationship. So they vary directly, as in the example we've just looked at. We're going to work out what's called the constant of proportionality. So in the do now task, that constant of proportionality was 30, because this is what we needed to multiply the speed by to get to the distance covered each time. We're also going to have a look at recognising graphs that show direct variation. So this chapter is going to show us how to solve problems where two variables are connected by a relationship in which they vary in direct proportion. We are then going to move on to look at how to solve problems where two variables are connected by a relationship in which they vary in indirect proportion. So that won't be till next week's lessons. And we're going to look at how to recognise graphs that illustrate direct. We'll look at some of this today, and inverse proportion next week. So we should already know then our squares, what square numbers are, square roots, cubes and cube roots of integers. Remember, an integer is a whole number. We should already know how to substitute values into algebraic expressions, and we should already know how to solve simple algebraic equations. About this chapter, in many real-life situations, variables are connected by a rule or relationship. It may be that as one variable increases, the other increases, just like the do now task. Alternatively, it may be that as one variable increases, the other decreases. In this chapter, you will learn how quantities vary when they are related in some way. For example, as plants get older, they become taller. As a car gets older, it is worth less, and eventually it is worthless. As more songs are downloaded, there is less money left on a gift voucher. So our success criteria for this particular lesson, we're going to solve problems where two variables are in direct proportion. We are going to work out the constant of proportionality, and in fact go further to work out an equation connecting the variables, and we are going to recognise graphs that show direct variation. So back to the table for Mo Farah then, where one quantity directly scales with another. For example, as one doubles, the other doubles. We say they are directly proportional. and there is a mathematical symbol for directly proportional, and that is this symbol here. It's called the constant of proportionality. It resembles a lowercase alpha. Remember, alpha is the Greek letter, although this isn't strictly true. Some people call it the fish symbol, but really technically it is just the constant of proportionality. So because the speed and the distance varied, as one increased so did the other, they're directly proportional, so we can write straight away that the distance is directly proportional to the speed, and this is how we write it. So based on our discussion that there's a constant scale factor between the two, remember that constant scale factor was 30, we can actually write this as a formula. And what we tend to do is we start with a formula of D is equal to KS, where this K is the constant of proportionality. And then we work it out. So we knew that we'd got to multiply the speed. So remember, this means times. We'd got to multiply the speed by 30. So K was 30. So this is where this formula comes from down here. So when you are working with direct variation, we start by finding the multiplying factor, or the constant of proportionality. So in the example, that was the 30. Then you can use it to solve a problem, which we'll look at in a moment. The symbol for variation or proportion is this symbol here. You can write the statement pay is directly proportional to time, mathematically as pay, proportional symbol, time. This implies that, so for some pay, it's a constant K multiplied by the time that you spend working. So K is the constant of proportionality. Let's look through some worked examples together. So for each of the examples we're going to look at, we always follow these steps. So it might be an idea to copy them down. So step 1, we set up the proportion statement using the proportionality symbol with letters or symbols to represent the variables. So in the other case, the distance was directly proportional to the speed. Step 2, we set up the equation using a constant of proportionality. So this means that D is equal to a constant of proportionality multiplied by the speed. So this is what this means. Step 3, we use the given information to work out the value of the constant of proportionality. So we worked out that K was 30, so we could work out that the formula was D equals 30S. Then we substitute the value of the constant of proportionality into the equation and use it to find unknown values. So we're going to go on to look at some worked examples of this. Step 5, if you are asked to sketch or identify a graph, it will always be a straight line starting from the origin. The gradient of the graph will depend on the value of the constant of proportionality. So if values are in direct proportion to each other, it's always a straight line starting from the origin. So the gradient for D equals 30S would mean that the gradient of the line was 30. So for D equals 30S, the line possibly would have been much steeper. So some worked examples. Y is directly proportional to X. So straight away for this question, we would write down, using the constant of proportionality symbol, this. Y is directly proportional to X. This would then give us the formula Y equals KX, and this is just what you need to know and be able to write down as soon as you see this sentence here. Then we use this information we're given. So when X equals 3, Y equals 7.5. So I'm going to replace Y with 7.5. And I'm going to replace X with 3. So this would mean then if I do 7.5 divided by 3, this means I can work out that K is equal to 2.5, and I can substitute it back into my formula. So the formula is Y is equal to 2.5K. So find a formula for y in terms of x. Sorry, this should have been x. Let's just smarten this up. So sorry, it was the k that's 2.5, so it should be y equals 2.5x. So that's my formula, and hence find the value of y when x equals 4.4. So now I would just substitute 4.4 into here to then work out what y is. So if I just have a look at the worked solution, so this is exactly what they've done. They've got y is proportional to x, which lends itself to this equation here. They've substituted the 7.5 and the 3 in and worked out that k is 2.5. Put this back into the formula, so y equals 2.5x. And then when x equals 4.4, they've worked out that y must be 11. Let's have a look at another one. You might want to pause the video and have a go at this yourself to see if you can do it before I go through it. So r is directly proportional to q, so r with the constant of proportionality symbol q. And remember, this means that r will be equal to some constant, let's call k, multiplied by q. We then use the we then use the values we're given to work out what k is. So when q equals 12, r equals 9. So r equals 9 when q equals 12. So here, now that I've got a smaller number over here, this doesn't matter. So it should be 9 divided by 12 is equal to k. And then you will notice that that's 3/4. So you could write k as 3/4. You could similarly write it as 0.75. So the formula then for part A is k is 0.75, as we've just done. So r equals 0.75q. Or similarly, you could have written that r is equal to 3/4 q. Or 3q over 4. That's entirely fine. Then for part B, find the value of r when q equals 17. So now take your formula and we are just going to substitute q is 17 into here. So we would get that r is equal to 12.75. Have a go at these two questions now, so exactly in the same way. So you can pause the video while you have a go. So question 1, given y is directly proportional to x, find a formula for y in terms of x. I've got y equals kx. Now don't ever leave it as this as your answer for the formula. You have to find k and input it back in. So when y is 12, x is 3. So this would mean that k equals 4. So this would mean that this is y equals 4x for the first one. For the second one again, y is proportional to x. This gives the formula y equals kx. Now when y equals 8, x equals 16. Be careful here because I'm doing 8 divided by 16. So this will give me 8/16, which I know is a half. So y is equal to 0.5x in this case here. There we go. Question 2, b is directly proportional to a. So this gives the formula b equals ka. When a equals 8, b equals 10. So b equals 10 when a equals 8. So 10 divided by 8 would give me k, or this is 5 over 4, isn't it? Or 1.25. So k equals 1.25. So b equals 1.25a. And then it says find the value of b when a equals 13. So you need to do 1.25 multiplied by 13 to get that b is equal to 16.25. So now here is the example from the textbook. The cost of repairing an article is directly proportional to the time spent. So let's go for R for repair. Actually, cost, I think I'll use C. So the cost of repairing an article is directly proportional to the time spent. And normally in an exam question, they'll tell you what algebra to use. So the cost of repairing an article is directly proportional to the time spent. We know that would give the formula C equals KT. A repair job that takes 6 hours, so that's my time, so it's telling me my time is 6 hours, costs £180. This means I can work out what my constant K is, so 180 shared by 6 will give me that K is equal to 30, so my formula would be C equals 30T. The cost is equal to 30 multiplied by the number of hours, the number of time. So part A, work out the cost of repair that takes 5 hours. So now that would be 30 multiplied by 5, so that would be £150. The length of time it takes to complete a repair costing 240, so that would be replacing the C with 240. And working out 240 shared by 30, and that gives that the time would be 8 hours. So let's get rid of my working now and just see how they've explained it here. So part A, step 1, they've got the C is proportional to T. Step 2, they've set up the equation C equals KT. Step 3, they replaced when C was 180, T was 6 to work out that K was 30. Step 4, they've put K into the formula to get C equals 30T. Step 5, they've replaced T with 5 to work out the cost was £150 for a job taking 5 hours. And for part C, they've worked backwards and worked out the time was 8 for a job costing £240. So now it's entirely up to you. You can have a go at some questions from the exercise. Maybe just pick out a few to have a look at. I wouldn't do all of them. But the answers are here at the end. Alternatively, you can wait for next week when I'll go further into this and also set you some Hegarty maths tasks on this. But there's no Hegarty this week. You should have done your circles revision lesson, you should have done the chapter 20 knowledge recall, and then maybe had a go at a couple of questions from here. So are we ready to progress? Well, hopefully you can recognise direct proportion. Hopefully you know what a constant of proportionality is and how to find it. And hopefully you can find formula for direct proportion. We haven't looked at inverse yet, and we can solve some problems with direct.